Okay, so two sets of parallel sides, and I'm showing you this on your picture. Okay. The next thing, the sum of the angles will equal 360 degrees. And when we're talking about the angles, then we know that the opposite angles are going to be congruent. All right, and adjacent angles equal 180 degrees. So basically I'm saying this angle and this angle are congruent, and these two are congruent. And by adjacent, we're talking next to, correct? So angles that are next to each other, so this one down here and this one up here will equal 180, or this one over here and this one over here will equal 180. Okay? Does that make sense? All right. 3. Opposite sides are congruent. So not only are they parallel, but they have the same lengths, same measures. And then finally, what I want to say is that the diagonals bisect each other. Okay, so when I draw my diagonals, did I say that the diagonals are congruent? I did not. There will be some figures where the diagonals are congruent. This is not one of them. But what I'm saying is that these diagonals create a point of intersection, and that point of intersection divides the diagonals into two congruent parts. So along the one going from bottom left to upper right, they're divided in half. These two are also bisected, but there is nothing that says that these parts are all congruent with each other. Does that make sense? So make sure you have that clear in your head. Along a given diagonal, they are congruent lengths, but the two diagonals together are not congruent to each other. Okay? All right. I'm not really sure why I had a fifth one, so we'll come back to that. All right. So I have opposite sides that are parallel. Therefore, I have a parallelogram. Yes? Uh-huh. Okay, so let's do it this way then. We'll make this one 3. Thank you. And this one 4 to indicate the difference. Yes. Athena? So you could notice that this triangle is congruent to this triangle. It should, sure. By angle, side, angle, or angle, or side, angle, side, sure. So you could say these two little ones are congruent. You could say that triangle 4 and triangle 3 are congruent. You could say that according to the diagonal here, the left side is going to be congruent to the top side. Y'all see how those are all congruent triangles? Look at the tick marks and you can see that the sides are all the same lengths. The angles are going to have the same measures. Okay. All right. So find x, y, and z. What is x going to equal? Yeah, that's easy. What's y going to equal? So we get that by subtracting 65 from 180 because adjacent angles are equal to 180. Okay. And how do we figure out what z is? Z plus 4 equals 12. Therefore, z is equal to 8. Okay. I had to think for a second because I know my math skills, basic, aren't always good, but I didn't think it was 3. Athena? I said I don't remember what I wanted for number 5, so if I remember, I'll come back. Okay, here we go. So let's see what we got here. I'm giving you that angle, the measure of angle D is 110 degrees. I'm giving you that the measure of angle DCA is equal to 80 degrees. I'm giving you that the measure of angle DEC equals, oh, that's 80. Sorry, the other one is what? 30. Thank you. Okay. So, measure of angle BDC. So you've really got to kind of think about this. BDC. What do you think? Okay. Do you see how we have a triangle? You got to look for triangles in this problem. We have this little triangle right here. And when I ask for BDC, it's the bottom left angle of the triangle. Do you see that? And so she's right. In a triangle, we have 180 degrees, don't we? So the measure of angle BDC plus 80 plus 30 is going to equal 180, which leaves me the angle BDC is equal to 70 degrees. Okay, if this is 70 degrees, and without even looking what other questions we have, what else can I immediately determine in this picture? Sarah? Yeah. Okay. And sometimes if you immediately find some information in these pictures, what you need to do is go ahead and fill in that information on your picture, even if it's something that I don't know if I want to find. Maybe it'll help you to find something else. So we know that this is going to be 40 degrees because the whole thing was stated to be 110. Is that correct? Okay. So did I ask for that at all? No. Okay. But that's fine. All right. So let's look at measure of angle CAB. CAB is this angle currently right up here. What is that one? Why is that one 30? Yep. Alternate interior angle theorem. We have parallel lines cut by a transversal. Your diagonal is going to be your transversal. So you've got to use some of these old theorems that we used in chapter 4. So this one and this one are cut through. I should have said that, but we were dealing with a parallelogram. So this is going to be a parallelogram. Good question. Okay. Yes. Nope, but I'm doing it on the notes so that when you go back and look at your notes, you'll know why I'm saying that. Okay. All right, EC. EC has what? Is what? Yeah. If AE is 2, then EC is 2, correct? That would make AC what? Yeah. Okay. Measure of angle AEB. So AEB is this part right here. 80 degrees. Why do we know that? What's our reasoning? Vertical angle theorem. DBC. Isabel. Okay, so not so much that the triangles are congruent, but again, what do we know about these two angles? Exactly, and that's why this is going to be 40, alternate interior angle theorem. Okay, how we doing? Here's my transversal. This, which we found, although we didn't need to, it alternates to this. Right, these are my parallel lines now. Okay. Kaylee? Yes, you do want to have these in your note cards. Thank you for reminding me. Properties of a parallelogram need to be stated. Okay? All good? Okay, I think that's it, isn't it, on this one? So let's do 8-3. Oh, actually, let's go to this chart. Can you what? Sure. Okay. Here's mine. So, what do we know about a parallelogram? Do we know that both pairs of opposite sides are parallel? Okay, we need to check there. Some of them will have only one side, so we don't want to do that. We're looking for the one that works the most, and so opposite sides are parallel. Are diagonals perpendicular? We are not guaranteed that a right angle is formed where the diagonals intersect. Are diagonals congruent? I did not say that either. Okay. Do the diagonals bisect each other? Okay. Do both pairs of opposite sides, are they congruent? Are all sides congruent? Mm-mm. Both pairs of opposite angles are congruent. Yeah? Sure, both pairs, right? Here and here. And then are all angles congruent? And then the last one says what? Are all angles bisected by the diagonal? Think about it. Go back and look. Look what we did on this one. Was our angle bisected by that diagonal? No. Part of it was 70 and part of it was 40. Okay? Isabel? Okay. Did I not say that? I think I put that on number 1. Oh, is that what I did? I just chunked them. Okay. That's fine. Okay, so this chart is going to be an ongoing chart for us. You're going to want to have that, keep updating it. It's going to be kind of your reference. Okay. All right, let's look at 8-3. So this is to prove. So given a picture or a set of points, 4 points that make up the vertices of a quadrilateral, I want to prove that what I have is a parallelogram. So if I want to prove, and you're going to want to have these in your note cards too. So there's a difference between a definition, how do we define it, and how do we prove it? Okay, to define it, we know to define it, it had to have those 4 or 5 pieces of information. To prove it, we have to prove just a couple of things. We don't have to prove all of those 5 or 4 steps. Number 1, we need to prove or show both pairs of opposite sides are congruent. Well, if I want to prove both pairs of opposite sides are congruent, what do I want to use if I'm given a set of points? The distance formula, yeah. If I'm going to show that opposite sides are congruent, then I have to use the distance formula. Does that make sense? All right. If both pairs of opposite angles are congruent, well, I can't really prove that. But maybe it'll show it. What's the matter, Sarah? Okay. Thank you. Okay, both pairs. So we need to be able to say that they are by seeing it in the picture. We really can't prove it right now. But maybe you can see it. One pair of opposite sides are congruent and parallel. So I choose a set of sides. I must show that they are both congruent and they are parallel. What am I using for those set of points? Slope for parallel, congruent for distance formula again. So we show that they're parallel, they have the same slopes. We show that their sides are congruent, we show that they have the same distance, the same length. Are we good? Okay. If the diagonals bisect each other, what would I do here? How would I show that? You would show that they have the same midpoint. Wouldn't that make sense? In other words, the midpoint of this one is going to bisect, isn't it? That midpoint takes my diagonal and divides it into two congruent parts, yes? They should share that same midpoint because they should also show that these then are the same. What else could you use? I guess you could show the distance from here to here is the same as the distance from here to here, but that's a little bit more of a lengthy process, isn't it? Athena? Right. Right. We're not talking about the angles. We're talking about the lengths. Okay. Both pairs of opposite sides are parallel. What are we doing for both sets? Slope. 2 times. Right? We got to do it for the left and the right side and the top and the bottom. So on this, both pairs of opposite sides, we're doing the distance formula 2 times. Okay? Sydney? I think they should have the same midpoint. Now, I don't really care which method you use. Be familiar with 2 of them. Okay? For proving purposes. You don't have to do all of these. Any one of these will guarantee that you have a parallelogram. So if I give you a set of points and you want to figure out if it's a parallelogram, you can do number 3. I can show that opposite sides are both have the same distance and the slopes are the same. And I'm done. I've proven that it's a parallelogram. Okay? So you do not have to do all 5 of these. Put these in your note cards. All right, these are note cards. Just put them all in one. And you might want to go ahead and say, well, remind yourself, what are you going to do? Okay, what would you use? What method? Slope, distance formula. How many times do I have to do it? Okay, so show the following as a parallelogram. If, you want to make sure that you are using the right set of coordinates, so I would highly suggest that you do a rough sketch. That you don't do, say that FG and HI are opposite sides if maybe they are really adjacent sides. You know what I'm saying? So I might give you the letters in alphabetical order, but the plotting of them might not give you that same rotation around your parallelogram. So -3, 1 is G. No, is F. 2, 6 is G. All right. 4, 5, 1, 2, 3, 4 is H, and -1, 0 is I, or J. Okay. So if I wanted to use both pairs of opposite sides are congruent, in other words, number 1, I'd be doing the distance formula, right? Okay. That means the distance of GH has to equal the distance of FJ. Am I done if I prove that? No, what else do I have to show? So then I'd have to say that GF is equal to HJ. Or I can say the distance of GH equals the distance of FJ, and the slope of GH is equal to the slope of FJ. Okay? You choose which one you want to do. Right? Work it out. Let's see what we got. What's the last thing that I can do? Well, the last easier one, I think. I think if you do the slope of GH equals slope of FJ, slope of GF equals slope of HJ. All right, so pick your poison and tell me if I've got a parallelogram up there. I think this is G, yeah, GF and HJ. I have to do 2 sets, 4 altogether, Athena. I have to show that these two are congruent, are the same, and these two. You have to do four of something. Two sets of slopes and distance, four slopes, right. Which one did you do, Abby? Okay, can you tell me what you got the slope of this side to be? Good. And what did you get the slope down here to be? So you got to get this one to be 1 also. And that's not it, though. I got to do 4 things, except for one of them. It's about flying out. Yeah. So slopes on this side are -1/2 and -1/2. Yeah, you got to do all 4. All right, Aaron? Okay, tell me. Okay. And really, I don't care if it's simplified. As long as you're showing me that they're the same, I'm not asking for an exact answer or, you know. And so then that means this one's root 50, right? Yep, that's what I got. Root 5 and root 5. Anybody do the midpoint? All right, find your midpoint for both of them. What's the midpoint of FH and what's the midpoint of GJ? And how do you find midpoint? You add your values and divide by 2. So if you're going to forget that, put that again on your note cards, how you find midpoint. All right? But for argument's sake, tell me what the midpoint is. Right, FH. You don't have to. You just have to find the midpoint. We're doing a third way, just for argument's sake. So are we in agreement? Did you all get 1/2, 3? Yeah. That's what you should get if you did your math right. That's what I got for both of them. So maybe that's the easier way because there's only finding 2 things, right? It is. But I'm always going to say probably that you have to have at least 2 ways in your bag of tricks. I'll probably give you prove if it is or isn't, because of course I'm never going to be nice and make them yes if they work, right? You're going to have to prove to me, and I'll say use one method for one problem and a different method for another problem. Yes. because it's always good to have a lot of things in your bag of tricks. Okay? Megan, you had a question? Yeah, careful of the negatives. Okay, anything else? Uh-huh. So you wouldn't be able to do that, other than maybe to show that it would be, like if it was a rectangle, you could show me that they're right angles. And you would do, how would you show that they were right angles? Exactly. Yeah. Okay. All right, last one. For what values is this quadrilateral a parallelogram? X. Oh, this, I think this, I'm showing you that these two are congruent, so if I want it to be a parallelogram, I have to make these two congruent, yes? So therefore, my equation would simply be what? Right. So 4x will equal 32, and x would have to be 8. So if this is, because it indicates here that these two parts are congruent, and so for it to be a parallelogram, according to how do we prove it, the other two have to be bisected. The other one has to be bisected too into two equal parts. Okay? All good? And that's all we wrote, yes?